Let us start with our discussions on cooperation in mandates. So we saw that there are different mechanisms of offering incentives incentives for cooperation in these networks. So primarily they are of two types. One is the virtual currency based systems. The other one is called the reputation based systems. So first we are going to look at the virtual currency based systems. And so nuglets is one of these types of systems where basically there is some kind of virtual currency mechanism that is used for charging or rewarding server usage or provisioning. So that means that nodes that use a service will have to pay to the nodes in terms of these virtual currencies called nuglets to the nodes that are providing the service. So the service providers are going to be going to get paid, whereas the nodes which require the service, they will have to in turn pay for it. So this is very similar to what happens in a real marketplace. In a real marketplace, when we go and we want to buy a commodity or we want a service, so what we do is that buyer will have to pay to the seller in terms of currency, right. So in terms of some money, and a similar sort of thing we are trying to simulate in these sort of systems, the virtual currency based systems. So one of the typical services, so it can be any service, so for any service that is offered by the provider, this sort of mechanism can be implemented. So a very simple kind of service could be the forwarding of the packets. So basically the node which is forwarding the packet, it is going to pay the node which is, it is going to get paid by the node which is sending the packet to it. Okay. So this is how this particular mechanism works, and this payment is in the form of nuglets. So therefore who pays? So whether the source pays or the destination pays, who pays for the service? So depending on that, there are two types of models that have been proposed. One is called the packet purse model, PPM, the other one is called the packet trade model, PTM, and in the recent times there has been another model which is called the hybrid model that has also been proposed, which basically has a mix of flavor of the PPM as well as the PTM. So let us look at this particular figure to understand how the PPM model works. So let us say that we have a multi-hop scenario, a network where there is a source node which wants to send some packet to the destination node, and it has to do it over a multi-hop path involving two intermediate relay nodes, as we can see in this particular figure. So basically what happens is, along with the packet in the PPM model, the source node adds these virtual currencies called nuglets and would send it forward. The intermediate node receives the packet along with the nuglets, keeps some nuglets and forwards it to the next hop neighbor, with the hope that the next hop neighbor would also do the same, and finally the packet is going to be delivered to the intended destination node of the packet. So as we can see over here, that if any of these intermediate nodes does not have the incentive of keeping some nuglets, that means that if there is not enough nuglets that are left in the packet along with the packet, then that packet is going to be discarded by that particular node. So it will not be forwarded further. So the onus is on the source node to add enough nuglets, so that enough nuglets to the packet, so that to ensure that the packet will be eventually delivered to the intended destination node. But as we can see that there are, although this model comes with some advantages, there are some obvious disadvantages. So for example, estimating one challenge or a disadvantage would be estimating what would be the enough number of nuggets that have to be added by the source node to ensure that all the intermediate nodes are going to keep some of them, so that there would be enough nuggets that will be still left when the packet finally arrives at the destination node. So, this is one thing. Second thing is how many nuggets the intermediate nodes are going to keep, that is another challenge. So, coming up with a model to determine how many nuggets each of these intermediate nodes are going to keep, and whether they are going to abide by that particular protocol that is set, is also another challenge in adopting this kind of model. So, this is the PPM model, and let us now look at some of the other characteristics. So, the source node basically loads the packets with sufficient nuggets at the time of sending, as I just said. The intermediate node takes some nuggets depending on the amount of energy that it has used, the battery status of the forwarding node, the current number of nuggets of the forwarding node, and so on and so forth. And as we have seen, a packet is discarded if it does not accompany with enough number of nuggets. So, the source node has to ensure that enough number of nuggets are added to the packet. So, advantages: it stimulates cooperation, it deters nodes from sending useless data and overloading the network. These are quite obvious. And disadvantage, I have already told you that it is difficult for the source node to estimate the number of nuggets that are required, because in that case the source node would have to know the number of hops the packet is going to take in order to get finally delivered at the intended destination node, and this particular information is typically not known to any source node a priori in an ad hoc network. Okay. Now, the other model is the Ptm model. In the Ptm model, we have a similar multi-hop scenario, but instead of the source node paying, that means adding enough number of nuggets, there is another kind of buying selling mechanism that is simulated at the between the intermediate nodes. There is some kind of a buying selling mechanism that is. So, basically in this Ptm model, what has to be ensured is that the intended next hop neighbor or the destination node has to buy the packet from the previous upstream neighbor. So, obviously in this model, if the destination node refuses to buy the packet, or an intermediate node in the chain refuses to buy the packet, then the packet is going to be discarded, it is going to be dropped. So, packets are traded for nuggets by the intermediate nodes. Each intermediate node buys the packet from the previous node for some nuggets and sells it to the next node for some nuggets. If the next intermediary node does not want to buy the packet for the given price, then the forwarding intermediary may try to sell it for a lower price or to another intermediary, or it may drop the packet if there is no other option that is remaining with that particular node. That means, no one is willing to buy at the same price or a lower price. So, in that case there is no other option and the packet has to be dropped. Advantages: the source node does not require to know the required number of nuggets in advance, and disadvantages are that the malicious source nodes may overload the network with useless data, right. So, this is quite obvious, and I do not think that I need to elaborate on this particular point of disadvantage. In the hybrid model, the properties of PPM and Ptm both are inherited. The source node here loads the packet with some nuggets before sending it, like in the PPM model. The packet is handled according to the PPM until it runs out of nuggets. So, till that point, until the packet runs out of nuggets, it will be PPM. Then it is handled according to the Ptm model, that means some other intermediate node or the destination will have to buy the packet from the previous neighbor, which holds on to the packet. So, the advantage of this hybrid model is that source still has to pay. It will try to avoid sending useless traffic and overloading the network, and the source can underestimate the number of nuggets that it puts in the packet, because the packet is not discarded when it runs out of nuggets. So, the way to control the number of nuggets that are charged for packet forwarding can be of two types. One is the fixed per hop charge, that means it is a fixed charging model. The other one is an auction based model, in the same way as we encounter auctions in a real marketplace. So, it can be a fixed charge model or an auction based model. So, in the fixed per hop model, charging model, same number of nuggets are kept for each forwarding node. That means, every forwarding node would be keeping the same number of nuggets. The advantages of implementing such a fixed model is that it is simple to implement, whereas the disadvantage is that this approach is not very flexible. The auction based mechanism, on the other hand, use a sealed bid price auction mechanism to determine the next hop. So, among the possible next hop neighbors, whoever bids the highest will be given the packet for forwarding it. Okay. So, the lowest bidder is selected by the forwarding node after receiving all the bids. The advantages of auction based mechanism is minimizing the number of nuggets that are spent, and the second is lifetime of the network can be lengthened or it can be prolonged by balanced energy consumption based routing. In terms of the disadvantages, this is not so simple to implement, it is rather complex, and there is a bandwidth and latency overhead. So, this method can be implemented only for multipath routing algorithms. So, the other type of mechanism is called the sprite. This is also a financial kind of mechanism, a currency based mechanism, but the way it operates is different from the way nuggets operates, nuggets based mechanism operates. So, here in sprite what we see is an adoption of some kind of mechanism by which the credit card companies operate. So, we have, as we can see in this figure, a scenario where there are large number of nodes, I mean a set of nodes in a network, in a wireless network, in a let us say MANET, and these nodes they would connect in this particular model. They have adopted this particular architecture. In the sprite model, this particular architecture is adopted. So, these nodes in the MANETs, they would be connecting to some kind of credit clearance service, a very similar kind of service as it appears in credit card credit card services, in real credit card services, and these these nodes are going to connect to the CCS via the internet. So, these systems use credit to provide incentive to the selfish nodes. These nodes keep receipt to get payments from the credit clearance services. The credit a node gets depends on whether the service is successful or not. So, these receipts are going to be kept by the different nodes, and these are going to be encashed from the CCS. So, each node in sprite is equipped with network interfaces that allow them to send and receive message, and to identify each node it is assumed that each node has a certificate issued by a scalable certificate authority. So, this is how it is securing this particular mechanism. So, when a node sends its own messages, it will lose credit. So, when you are sending, you are doing it at the cost of your own credits. So, when a node forwards the others messages, it is earning the credit, very similar to what we had seen in the PPM model or the like. The Ptm also very similar. A node can gain credit in two different ways. A node can pay its debit or buy more credit using real money. So, basically using real money also it can buy some credits, and by forwarding others messages. These are the two different ways in which a node can gain credit, it can buy credit, it can get more credit from the system. So, selfishness is something that is typical in Sprite. So, after receiving a message, a selfish node may save a receipt and would not forward the message. So, this is something that can still happen and Sprite is vulnerable to that. The countermeasure to tackle this kind of selfish behavior would be that the CCS, that means the credit clearing service, should give more credit to a node that forwards a message than to a node that does not forward the message. Okay. So, the other selfish action could be that after receiving a message, a selfish node may not report the receipt, and the countermeasure for this would be the CCS charges the sender an extra amount of credit if the destination does not report the receipt, so that the colluding groups get no benefit. So, this is quite obvious countermeasure to counter this kind of selfish action. So, these are the two different types of selfish actions that can occur, and these countermeasures are also mentioned. Another one is that in Sprite a group of colluding nodes may forward only the receipt of the message instead of forwarding the whole message to its successor, you see, and the corresponding countermeasure is mentioned over here. And so, here actually what would happen is, if the destination colludes with the intermediate nodes, the intermediate nodes and the destination should be paid as if no cheating had happened and no submission of on submission of the receipt. So, let me repeat that if the destination colludes with the intermediate nodes, the intermediate nodes and the destination should be paid as if no cheating had happened on submission of the receipt. If the destination does not collude with the intermediate nodes, the credit paid to each node should be multiplied by a fraction r, where r is less than 1, when the destination does not submit the receipt. Okay. So, this is a countermeasure against the third kind of selfish action that can be adopted by any of the nodes in Sprite. So, these are the three different ways in which a node can behave selfishly even when adopting Sprite. So, let us look at the virtual currency systems as a whole. So, neglect based mechanism basically it is attractive, but the disadvantage is that adoption of such a mechanism would require implementing some kind of tamper proof hardware to control the number of nuggets that are charged. Sprite in particular requires a central server to determine the charge and credit to each node. So, both of these systems, whether it is the Ptm, that means the nugget based system, or the Sprite, have two different types of advantages. Additionally, both of these systems, they suffer from something well known as the location privilege problem, which means that the nodes in certain locations of the network have a better chance of earning credits, which may not be fair for all the nodes in the network. So, certain nodes get privilege over other nodes due to their locations in the network. On the contrary, there is a whole separate class of systems for countering misbehavior, which is called the reputation based systems, which have been proposed, which again does not suffer from some of these disadvantages that we have seen, but they have their own set of advantages, other set of advantages and disadvantages. As the name suggests, reputation systems are basically where the reputation of the behavior of the different nodes are kept track of, and based on the reputations that are tracked, and based on that the routing decisions are made. So, reputation systems can be classified into two types. One is the centralized reputation systems, very similar to what we see in systems like the eBay or Flipkart and so on, where basically the reputation of the buyers and the sellers are kept track of in a centralized manner. That means there is one or more servers who keep track of the reputation of the buyers and sellers in a centralized fashion. Decentralized reputations are basically typical in minutes, where each node keeps the ratings of other nodes in the networks, and based on this particular activity they update the ratings by direct observation of the behaviors of neighboring nodes or second hand information from other trusted nodes, either through direct observation of the behaviors of the neighboring nodes or from second hand information from other trusted nodes. This is how the decentralized reputation mechanisms which are typically adopted in manets works. The three goals of reputation systems are to provide information to distinguish between a trustworthy principal and untrustworthy principals, to encourage principals to act in a trustworthy manner, to discourage untrustworthy principals from participating in the service the reputation mechanism is present to protect. So, these are three important objectives of reputation based systems. Examples of specific examples of protocols belonging to this class of systems are confident, core and ocean. All of these three are basically acronyms. The corresponding full forms are not given over here, but these are well known by these particular acronym names: confident, core and ocean. So, the reputation systems can be of two types: the global reputation system, where basically each node knows the reputation value of every other node in the network, and this can be achieved by exchange of indirect reputation message among the different nodes in the network. Confident and core specifically belong to this particular category. There are several disadvantages also of adopting a global reputation system. First is that each node maintains the reputation values of every other node, and that is not a very good thing because it would cost a lot of storage, and that is not very ideal in manets which are already resource starved. Second disadvantage is disseminating reputation information greatly increases the volume of network traffic. Too much of network traffic, so because these are control packets kind of, right. So, this reputation information, these are not carrying the actual data, the actual traffic that has the data, right. So, this additional volume of traffic is unwanted, but at the same time, so if you have to adopt these mechanisms, you have to use you have to increase the traffic with this kind of additional information. The decision and incorporating second hand information consumes additional computation, and the reputation information could be modified, replayed or accidentally lost during transmission. These are the four different distinct disadvantages of this class of reputation systems. In the local reputation system, basically each node only keeps the reputation value of its neighbor nodes. So, unlike in the previous case where we have seen that each node knows the reputation value of every node in the network, here each node only keeps track of the reputation value of only its neighboring nodes. Okay. And instead of distributing the reputation value or information periodically, the local reputation systems usually update the reputation value based on its own observation. So, I told you that confident basically is a kind of protocol that belongs to the global reputation system category. So, in confident, the full form of which is cooperation of nodes, fairness in dynamic ad hoc networks. In confident, what is done is one detects the confident basically detects the misbehaving nodes and it isolates them from communication, but by not using them for routing and forwarding and by not allowing the misbehaved nodes to use the use itself to forward packets. So, here in confident we have three different components. One is the reputation system, the monitor, first of all the monitor, the second is the reputation system, and the third is the path manager. So, three different components that basically are there in confident. So, monitor basically what it does is it is like the watchdog. So, it keeps an eye on the behavior of the different other nodes in the network. Reputation system basically based on the behavior, it is going to assign some reputation values to these different nodes, and the path manager what it does is based on the reputation values that are maintained by the different nodes, it is going to calculate that which node, which paths comprising of which nodes would lead to higher reliability of delivery of packets. So, this is the block diagram for the, rather it is a state diagram, right. So, it is not a block diagram. So, this is a state diagram, and so here as we can see that there are different states and the corresponding so to transition from the different states, corresponding activation messages that state transitions that are going to happen to transition from one state to another. Okay. So, these are the components of a node when implementing confident, monitor, trust manager, reputation system and path manager. Confident uses alarm messages which are sent by the trust manager of a node to warn others of uncooperative nodes. The outgoing messages are generated by the node itself after having experienced, observed or received a report of uncooperative behavior, and the recipients of these messages are friends and are administered in a friends list. Okay. So, basically in essence what it is trying to do is it is going to send to its own friends, a node to its own friends, it is going to send some kind of an alarm or a warning message saying that there are few other nodes which are uncooperative nodes, and these nodes should be aware of those nodes. Another mechanism which was proposed around the same time as confident is called the core, the full form of which is collaborative reputation, and it also operates in a similar manner to confident. Here basically three types of reputations are used. First is the subjective reputation. So, this is basically the reputation of a target node which is calculated directly from a subject's observation of the target node's behavior. Indirect reputation, which is evaluated only by considering the direct interaction between a subject and its neighbors, and the third is function reputation, which is the subjective and indirect reputation which is calculated with respect to different functions such as forwarding a data packet, reply route request and so on. The basic components of core are very similar to that of, in principle they are very similar to that of the components of confident. So, here we have the reputation table, the first component, and the watchdog mechanism. So, I am not going to explain these once more, because it is the whole concept is quite similar to that of the similar kind of component, the parallel components that we have seen in the case of confident. OCEAN basically is another kind of reputation based mechanism. The full form of OCEAN basically is observation based cooperation enforcement in ad hoc networks. OCEAN basically disallows second hand reputation exchange. It makes routing decisions based on the direct observations of its neighboring nodes through interactions, and in OCEAN again a different set of components are resident in each of the nodes. So, the first one is the neighbor watch, the second is the route ranker, the third is the rank based routing, the fourth is malicious traffic rejection, and the fifth is second chance mechanism. So, these are the different reputation based mechanisms that are very popular in the literature. So, confident, core and OCEAN, but reputation based mechanisms, although they are very attractive, they basically have work under certain assumptions of trust, for example, that you are trusting your neighbors, or particularly if you are exchanging second hand information, if you are handling second hand information, you are trusting, indirectly you are trusting the other nodes in the network. So, without a priori trust relationship or a trusted management mechanism, these systems may be destabilized by false rating, either false accusation or false praise. This is a very serious limitation of use of reputation based systems. So, the nodes have to keep, update and share routing information, which basically causes more overhead both for individual nodes and for the network. This is another serious limitation of adoption of reputation based systems. So, with this we come to an end of the whole topic of cooperation in manets, and we have already seen in this particular module that there are different ways in cooperation in which cooperation can be enforced in manets, because cooperation is a very important thing in these networks. It is very important to ensure that the nodes, the intermediate nodes, they cooperate with all other nodes, that particularly the source and destination nodes, if we are talking about routing specifically, or for any other services that a network offers. So, the cooperation between the different nodes is very important, and there are good reasons which are attributed to the different limitations, the resource limitations of these networks, due to which cooperation between the different nodes may not happen as desired. So, in order to promote cooperation, what happens is there are different mechanisms that have been proposed, virtual currency based mechanisms, packet purse model, packet trade model. These are examples belonging to this particular category. Sprite is another one, which is a bit different from the PPM and Ptm, but again Sprite also belongs to the virtual currency mechanisms. So, these are the three, and then we talked about the reputation based mechanisms, where reputation of the different nodes either locally or globally is kept track of by the different nodes in the network, and that information is shared with the different nodes for helping them determine which intermediate nodes have to be adopted for sending a packet from a source node from one of the from each of the source nodes to the intended destination nodes. So, for belonging to this reputation based system category, we have confident, core and ocean, and we have also seen that confident and core, they suffer from the location privilege problem. So, that means that if some of these nodes they they occur in some part of the network, if they are in some part of the network, these nodes they get privileged from the services compared to the other nodes in the network. So, their location basically helps them to get privileged. So, with this we come to an end of the entire topic of cooperation in ad hoc networks. Thank you.